Okay, so this is one of the questions from the student. This is an Atkins Physical Chemistry textbook, 11th edition. The question is exercise chapter 4a. So what's the maximum number of phases? So that's a P, and can be obtained in a mutual equilibrium of two component system. So when you have a two component means C is 2, that's a two component. And then that's the maximum is what they were looking for. So A, the equation that you can use is as a Gibbs phase rule, C minus P plus 2. And in this case is because C is 2, that's C is being 2. So you can say 4 minus P. Okay. And so therefore you can say P is actually 4 minus F, and the max the minimum F that can have is a 0. Okay, it is like a point in phase diagram. There is no degree of freedom, and so that's the minimum value that you can have. So therefore, the maximum P is 4 minus 0, which is 4. So there is 4 phases can coexist in here. So number 2, same thing. Now the number of phases, the 4 component system, so it's the same problem, but now number of components 4. It's a kind of a lot of components in the mixtures. So the C is 4. So therefore, the number of phases, which is a C plus 2 minus F, that can be 6 minus F. Once again, F is 0, that's a minimum value. So therefore, P is 6, that's a maximum value. Okay, so there are maximum of 6 phases can coexist. So 6 phases can coexist for 4 component mixtures. So probably what do you mean by 6 phases? Even for the same crystal solid, depending on their crystal structures, they can have a different density, different physical properties. So even what we call solid, there are different crystalline structure corresponding to different phases. Okay. One last one is, I think that is pretty common for us to see this phase diagram for when C is 1, single component system. Remember that? And so then in that case is P is 3 minus F. So therefore F is 0, that's a minimum value. And that's where you're seeing the P is 3, that's a maximum value. Right? So remember that when you draw the phase diagram, the pressure, temperature, typical phase diagram looks like that. And this is a point we call the triple point, which is solid, liquid, gas. And this is where degree of freedom is 0, but P is 3. Right? 3 phases coexist at the same time. So single component system, the phase diagram is easy to draw. For more than for the mixtures and so on, actually we have to discuss in a separate chapters. Okay, thank you for your attention.